Hello guys, tutorin/LearnSwain here, and welcome back to episode 6 of the Commandore 32 tutorial series. In this episode we'll continuing with the GPU stuff. So I should probably get this out of my inventory. As you can see, last episode we drew some shapes. I changed it a bit so you can see the colors a bit better. I moved this shape a little, not much changed. Here's the source code, still 3 lines. And yeah, so now we're gonna do some bit more advanced stuff than just drawing some random shapes on the screen. We are going to draw a dot on the screen, a moving dot. Yes, the most advanced thing ever made in Minecraft, truly. Yeah, it's not gonna be anything too advanced, but I'm gonna show you a lot of GPU features that are extremely useful in more advanced programs. So for this we're going to need variables, because we're going to move this square across the screen, and we're going to have pixel x, because we're only going to need to track the x coordinate, because we're going to move it across the screen. We're not going to move up and down, that's going to stay the same. So what we're going to do is going to say pixel x, and where are we going to start? Let's start at coordinate 7 perhaps, or should I maybe start at, now let's start at 3. I'll make the y 7, and then while true, I'm just gonna have this run forever. GPU dot plot, which is put a single pixel at coordinate pixel x, and I don't know, let's make that 7. I said it was gonna be 7. We're gonna set the color to something else. Gonna set it to color 5, whatever color that happens to be, and yeah, pixel x plus, so then it moves across. Not sure if I explained this in previous tutorial episodes, but this basically does the same as pixel x equals pixel x plus 1. I think I did mention it. But yeah, so it's gonna plot a pixel at 3, 7, then at 4, 7, then at 5, 7, then at 6, 7. So it's gonna look like it's moving across the screen. Simple enough. Okay, and we reset as usual. And you will be noticing a problem with this program when it runs, is that it will basically leave a trail of whatever color 5 is all over the screen. So as soon as it's done drawing the shapes and it starts drawing the little box, there it is, it was yellow, that was the color, you'll see that it's not actually erasing the previous pixel. So it's pretty much just going through everything, and it's just making a continuous line that is yellow. And perhaps I should start at 0, so I go through this green line as well. So right now I'm starting just after the green box. You'll see that it'll go across there, so I'll start it off at 0 for the next time. I'm going to leave this running for a bit. So a solution to this that you might think is perhaps u dot plot pixel x 7, and we'll set it to color 0, and then we'll set it to color 5 afterwards. In which case we'll start at pixel 1 actually, technically, because of how that works. You're going to see it go through the green line as well. There we go. I'm going to stop it for now, because it's running an infinite loop. Stop. Okay, I'm going to see if it stopped, and we're going to upload this new version. So what it's basically going to do is it's going to erase the old pixel and then put the new pixel in its new position, then erase this pixel and then put another one. This is pretty much how a lot of systems worked. It's a pretty okay way to do it. But because we have shapes in the background, this is also going to have problems, as you will see. Because it's going to erase the shapes as it goes through them. So there's a little pixel. I accidentally set color 0, which was white and not black. Silly me. As you can see, it replaces the pixel and then it moves on. And then it keeps going. So let me just change this to color 16. Sorry about that. Be right back. Alright, so sorry about those technical issues or my lack of checking the manual for what color codes are. But yes, now it should work. Now we get the pixel, it'll disappear, and it will move along. Now because this computer is so slow, you get to physically watch the pixel disappear and move. And there's a solution to that, which we're going to solve first, before we solve the problem of it erasing everything as it goes along. So you can see it disappears, and it moves over here. Wait for it, there we go. And then it will disappear, and it will move over there. So to prevent that thing from disappearing every time, we're going to use something called double buffering. Now basically what's going on right now is you're watching the screen as everything happens. Every time something happens on the screen, you're watching it. So every time something is put on the screen, sometimes some shape is being drawn, you're watching it live. In a real computer, there's something called buffering going on, where it basically builds a picture with all the shapes and stuff it needs to use, and once it's done drawing that picture, it sends it to the screen, clears it, and draws another picture. And in the meantime, you're looking at the previous picture it made. So you're not looking at the half-finished product as it's being drawn, you're looking at the last finished product it was making. Well, it has made, if that makes any sense. It probably doesn't, sorry. I can't think of any other way to explain double buffering at the moment. Basically what the user sees isn't what's actually going on. The user sees like a picture and it's perfect, and meanwhile in the background it's busy creating the next picture for the user to see. But it doesn't get to see it while it's being made. So it makes things look a lot more professional. By default, double buffering is off, but you could turn it on with a simple little command. If I can find it. Here it is, gpu.push. This little function over here will basically, once you use it, it'll take whatever you're making, whatever frame you're busy rendering, all the shapes that are currently on the frame buffer, and it will show it to the user. As soon as you've used this command once, it'll automatically put the computer, or the GPU, into double buffered mode. So if you put it all the way over here, it's going to automatically turn on double buffered mode, which means it won't see these shapes being rendered until we push it again over here. Now for now, so well yeah, let's do that, and let's also do this. So basically we're basically turning on double buffered mode here. Also turn it on so we don't see the screen until these two shapes are done. Once those shapes are done, we push it, so this user will go from seeing a black screen to seeing these two shapes on the screen without watching it being made in between. Then we go through here and we erase the old pixel, which from the beginning of the program there is no pixel, which should probably start at -1, which will make it look a little nicer. And then we make the new pixel, and then we show it. Then, now the user can't see this, we're erasing the pixel, the user's still seeing that old pixel, we're moving across, we're making the new pixel, and then we show that new pixel, or the newly moved pixel, to the user. So I hope that makes sense. Basically the user isn't watching the, oh, I'm still running my program, hold on. Forgot to turn it off. It's fine. You can move around and use buttons while things are uploading, by the way, but you cannot walk around. You can't use WASD because then you'll start typing, which will mess with the scoreboard commands because of course they're being typed in. Alright guys, sorry about that, some technical difficulties with uploading. You should always upload twice. But now it works. I just don't always upload twice because I'm kind of in a rush for these tutorials, and rather I've gotten bored of it. But if you wanted to guaranteedly upload twice. So yes, as you can see, we can't see anything because the screen's black, and that's because we use gpu.push at the very beginning of our code, which means we don't see anything until it's finished, as you can now see. So then, after those shapes drawn, then we use push, so then we see it, so we don't watch the square being drawn, and these two lines being drawn, and those two lines being drawn. Now we just see the finished product. As you can see, the pixel starts over there, and now you'll see it instantly teleport over there. You won't see it disappear and reappear there. As you can just see, it just instantly teleported, and that's what we want. So it looks very nice, very smooth, and this is especially useful if you have a lot of drawing things which takes really long, because as you can imagine, if you have a lot of shapes that you need to draw and you need to do a frame update system like I'm doing, sorry about that Skype message, I should have turned that off, then you'd basically spend like 10 minutes rendering all the shapes, and then it would only show up completed for a few seconds, like with all the shapes on it, and then it would be cleared, and then it would start up with the next frame. So with double buffering, you can just show that frame for the 10 minutes that it takes to make the next one. Now as you can see, we still have that problem that we are basically erasing everything as it's moving along. So see, we took a piece out of that green square, and we're taking quite a large piece out of this blue rectangle as it's going along. Now the solution to that is a little feature on this GPU called the general purpose frame buffer. So right now we're working with two frame buffers, the working buffer, which is the buffer we're making the shapes on, and the user buffer, which is the buffer we are looking at right now with our eyes. The other one's hidden. And the general purpose frame buffer basically allows you to take a screenshot of the screen as it currently is, and then you can recall that screenshot. So you could save the screen, take a picture of it, and at any random point in the code you can just load it, restore it, and it will be exactly the same way it was when you saved. If you've ever used like an emulator to play like NES games or Game Boy games, you would know like save state, load state. If you use a save state and you load it later, it'll be exactly as it was when you push that save state button. This is pretty much what our general purpose frame buffer will do, except it will only affect the GPU and not the rest of the computer. So we're going to stop this program now. We get the point. I mean, you could do some more advanced code where you detect whether we're in the blue square, and then if we're in the blue square, we'll draw blue pixels in the background instead of the black pixels, which is what we're doing right now. And you can then detect the green square, and it's all this complicated stuff, but this computer, it would be very slow and it would take really long to code. So what we're basically going to do is we're going to throw this command out the window, and once we've made our little picture, we're going to go gpu.save, if I spell it correctly. And what's that going to do? It's going to take a picture of this blue square and this green square, blue rectangle, green square. It's going to save it as it is, and it's going to remember it, and we're going to go gpu.load over here. So what this is basically going to do, it's pretty simple. So now we have a picture of just this blue square and just this green rectangle, and we save that picture to memory. And every time we want to move this little box, this little pixel, we basically take this picture with only the blue rectangle and the green rectangle in it, we put the yellow square on it, and then we show it. And then for the next time, instead of erasing the pixel the green square was on, or the yellow pixel was on, we simply restore the whole thing back to where there was a green square and a blue rectangle without the pixel. So the pixel will be gone, it'll just be the blue square and the green rectangle. And then we put the yellow pixel back on that picture. And then we basically keep doing that. We just clear everything but the blue square and the green rectangle. Now, of course, what you could also do is you could remove this and put these commands in here. That will also work, as you may know, because what this GPU.load is basically it restores these two things. So if you just draw the things over again, it'll do the same thing. But of course this is very slow, because now you have to render all this again. The GPU needs to find out how those pictures work. You need to send it all to GPU. It's much easier to do it this way, especially if you have a lot of shapes on your screen or like a very complicated system. I use this for tic-tac-toe. I use this for the paint program as well, I think. And I mean, you can't remember every single thing the person painted on the screen. It's much easier to just take a picture of it and use that. So this is very useful if you want to move around a cursor or something on the screen, or if you want to make a paint program that saves the pictures and then you can load them later. You could do that too. So yes, we're pretty much saving the square and the rectangle, and then we're loading it. So I hope I have said that enough times. You're gonna see it in action. I don't think I've explained it properly. I feel like I haven't explained it properly enough. So. And me just saying it over again doesn't really seem to help, does it? I saw it skip some commands. I'm gonna have to redo this. Don't worry, you won't have to watch it. Alright, so our new program is now gonna run, and we should have fixed all the issues we have had with our previous attempts to move a pixel on the screen. So I know this is a lot of work to just move a pixel on the screen. I did this sort of intentionally, that it's a simple example that needs a complicated solution, but this could actually be used for a lot more advanced programs. I'm just demonstrating it on this because it's just much simpler to understand than on, say, like a tic-tac-toe game. So here's our little pixel. Now note that we aren't setting this square to black anymore like we did in our previous version. We're loading it, and as you can see, it looks exactly like the other time. So we're pretty much loading it before this pixel was here, and then we're putting the pixel on it, and then we're showing it, and then we're repeating that process. But the difference is between putting the black pixel there, you will see now when the pixel decides to move. There we go. As you can see, that pixel is still green. Before it would return to black if you've been paying any attention, but now it remains green. And there could be any amount of shapes on this screen. It could be complete color garbage, it could be a picture of a rainbow, it could be anything, and this pixel moving across the screen wouldn't damage it. So this is obviously useful if you want to make a paint program like I did, and you want to move the cursor around. If that yellow square was, for example, the cursor, the little paintbrush, and you want to move left, right, up, and down without destroying the picture. So you want to say select a little square or something, you could do that. And as you can see, this blue square is still perfectly fine. And this is actually a little faster than the set it to black and set it to yellow process, as you can see as well, because we're not giving the GPU coordinates for the plotting the pixel one. We're basically copying the coordinates. We're saying, okay, draw a pixel here, here in this color, and we need to copy all that to the GPU. And Steam is giving me random notifications, sorry about that. But yes, all we're doing is telling the GPU, load that last picture you saved, which is much faster to tell the GPU. So despite it being a more complicated operation, or seeming a more complicated operation, the loading the previous image is a lot faster. And what would definitely be a lot slower is if you just copied and pasted this over here. That would be very slow. So this is best, just keeping it like that. So there you go. It's going to go over the green rectangle again, and it's going to be fine. So thanks for watching. Hope you enjoyed it. In the next episode we should do some, perhaps might do some more advanced GPU stuff, or I might do some low level stuff. I might start working around with registers. GPU's got a ton of registers, so I could sort of combine them as well. And perhaps break and return, continue, those statements. So as you can see, it's passed completely through. So you could tell me in the comments what you would prefer to see first. I've gotten the main GPU stuff out of the way. There's still a bit more low-level GPU stuff to make the GPU programs run a little faster. I know for a fact that I can make this program a lot faster if I do some certain things, but I avoided doing them to make this tutorial a bit more simple. So thanks for watching, hope you enjoyed it, and bye!